Throughout the presentation, Ryan invites you to do that, and that includes those online through the chat.
All right, so our presenter today is Ryan Kreiner. He's been working fisheries-related jobs out west for over 20 years. He got his Bachelor's of Science from University of Montana and Master's of Science from University of Idaho. He was working up in Northwest Montana with Montana FWP before moving to Dillon about 2 years ago, where he's been working as a native fisheries biologist with FWP. Primarily focuses on Arctic grayling and Westslope cutthroat trout and management, enhancing habitat, etc. He'll get into that more, but I want to thank him for coming today.
Thank you guys. I've been working for Fish, Wildlife, and Parks for about 15 years. Moved to Dillon in 2020, and now I'm focusing strictly on native fish conservation. And so I work in Region 3, which is all of Southwest Montana. So we've got these 9 subbasins here. There's 4 of the standard FWP management biologists that manage these areas, and I work amongst all of those regions. So I kind of work with the management biologists to help coordinate and get things done for native fish. And it would apply to any native fish species that was in need of work or conservation, but right now our focus is really on these 2 species, Westslope cutthroat and Arctic grayling. So that's what I'm going to talk about primarily. I thought what I'd do is just go in one species at a time, kind of talk about where we're at with both of these fish species, some of the threats, why they've declined, what we do to conserve them. There's really 2 different types of management actions we use for both of these fish. I'll start regionally and work my way down and talk about Madison specific projects. And then at the end, I thought, there's a whole lot of other native fish in Region 3. If you guys have any questions about those, I can try to answer them as well. So we'll start with the Westslope cutthroat trout. It is a subspecies of cutthroat trout. Cutthroat trout are a western trout species. It's one of the 4 major subspecies. So Westslope cutthroat trout are native in Montana. They're native to the Columbia River, the Saskatchewan River, and the Missouri River basins. They began in the Columbia River and eventually kind of invaded over the divide into the upper Missouri River and the Saskatchewan River, which drains up from the north side of Glacier Park. So that's how they got there. They were first documented by Lewis and Clark when the expedition caught Westslope cutthroat trout near the town of Great Falls on the Missouri, and there were many accounts in Lewis and Clark's journals of catching Westslope cutthroat trout. And so some of the threats for Westslope are pretty similar to what you see for a lot of, reduced native species. In the upper Missouri, the primary threat for Westslope cutthroat is non-native species. They hybridize with rainbow trout, and they get outcompeted by other non-natives like brook trout here. So what you have are these really small isolated populations, because the only place Westslope cutthroat trout still exist are where they're isolated from non-natives. So back in the 90s is when concern for the species really arose, and they were actually petitioned to be listed under the Endangered Species Act in 1997. And that prompted a guy named Brad Shepard, who at the time worked for Fish, Wildlife, and Parks, to initiate a status and risk assessment. So they wanted to see where we still had these fish and what we needed to do to get them back. Fish and Wildlife Service determined that they were not warranted for listing because of the ongoing conservation measures and wide distributions. We've since had another status and risk update. That was in 2005. And in 2007, we signed a memorandum of understanding between 22 different agencies, NGOs, things like Fish, Wildlife and Parks, Forest Service, Park Service, Greater Yellowstone Coalition, Trout Unlimited. And so we've all signed this agreement, and our goal in the agreement is to ensure long-term self-sustaining persistence of Westslope cutthroat. And in the Missouri River headwaters, we believe we can get there if we restore them to 20% of their historically occupied habitat. And also, I mentioned that cutthroat trout hybridize with rainbow trout and with Yellowstones. Anything for conservation purposes, anything that's 90% or more Westslope cutthroat trout is considered a conservation population. So this is a map from that 2005 risk assessment or status update that I said. And you don't really need to know all the colors. You just need to see that the gray are the streams that used to have cutthroat that did not have cutthroat anymore. And if you look up in the northwest corner, there's still a lot of color. There's a lot of cutthroat up there. Down in southwest Montana, you had a lot of gray, like used to have cutthroat, didn't anymore. And you can see the little colored dots are really small and isolated. So that's what we were dealing with. Just little tiny fragmented populations of cutthroat. And so currently, the colors are a little bit different, but you can see we're still in a pretty fragmented state. Green are 100% fish. Then we've got some mixes here, but you can see in the Madison, it's kind of hard to tell, but there are some pretty big projects that I'll talk about in there. So I mentioned our goal, 20% in each of these 9 subbasins are really our primary method to restore cutthroat is to isolate them from non-natives. And we can make gains towards that 20% with some of the really large projects we have going on. And right now we have some big ones. We've got a French Creek in the Big Holes, like a 40-mile project we're working on. Spanish Creek is in the Gallatin. It's just over the hill from Cherry Creek on Turner's property. It's about a 17-mile project. 16-Mile Creek is in the upper Missouri. That's a 7-mile project, and we're about to start on Selway Creek, which is a 40-mile project up in the Red Rock drainage. And we were going to start that last year, but a fire broke out and canceled it for the year. So we're working on big projects to get miles towards that 20%. But along the way, we're also losing some small unprotected populations. So we're trying our best to kind of protect as many smaller populations as we can.
Ryan, when you were talking about the MOU, did any organizations that are not conservation oriented sign the MOU?
Yes, I don't have them all memorized, but it was Plum Creek Timber Company at the time. It's since sold. It was then Weyerhaeuser, and now it's a different timber company, but that's an example of one that's part.
Okay.
So another thing to note, about 40% of our unaltered populations in this region are still at risk. So while we're gaining ground in some areas, we're also losing populations. And so right now we're focusing on protecting some of these smaller populations. We can either protect them in place if we feel like we can build a barrier in that stream, get rid of non-natives and protect them in place. But in some streams, it's not physically possible to even build a barrier. And in those cases, we might move that population to a different stream. So the next couple slides are just some pretty busy tables. I just want to point out that this first column is what we're basing our goals on. This was the estimated number of miles historically occupied by cutthroats. So in the whole southwest Montana, we estimate there were almost 16,000 miles of stream occupied. Currently occupied by pure cutthroat, we're at about 2.7% of that. So we've got, but I did mention 90% and above counts in our mod. So in that case, we're at about 6.5%. So that's towards that goal of 20%. If you notice here, the Madison does have the highest percentage at about 16%. Yes.
Just a quick question. So are they just more sensitive species? Why they?
Yep, they're very sensitive to non-native fish. They're actually pretty tolerant of warm temperatures. They can live in pretty degraded habitat, but they do not.
They don't compete well with the rainbows and the browns.
And the brook trout, yep. Yep, and the rainbow trout hybridization is a big one because they will just, you know, a population of cutthroat, if rainbows get in it, will just gradually shift and eventually just be a hybrid swarm of basically half rainbow, half cutthroat. So, but yeah, they don't compete well with brook trout either in those small little streams. So, but yeah, so I'll talk about the Madison eventually and why this number is so much higher in the Madison, but you can see we're trying to get to 20% in each of these and, you know, closer in some than in others. And one more table. These are just basically, we know that we have 187 conservation populations left in southwest Montana. And so you can go through and see Madison, we've got 7 unaltered populations and 13 that are 90% or better. But these are just things we're kind of tracking to help us get towards our goals. And so here's some of the tools that we use for cutthroat trout conservation. This is a man-made barrier that we built on a stream called Cottonwood Creek. And I'll talk about that project. It's in the Beaverhead, but we're actually working on that project right now. And tomorrow morning, we're going to be out doing a fish removal there. And we do remove fish. We do, in order to conserve cutthroat, we have to kill other fish. I'll talk about that in a second. And then I mentioned transfers. We do move fish. This is a coworker of mine packing fish into a recently vacated stream. We removed fish for a couple of years, verified it to be fishless, and then we're packing cutthroat back up in there. So I thought I'd talk about rotenone for a second. Rotenone is a compound that we use to kill fish. It's a natural compound found in tropical plants. In the 1930s, basically some people discovered it by observing some of the native tribes down there using this plant, chewing on these leaves, mixing them up in water bodies to kill or stun fish so that they could eat them. And so since then, we've sort of evolved that technique into a fish management tool. So it's a natural pesticide, but it's regulated by the EPA and the Montana Department of Administration. So, you know, I'm actually a certified applicator for rotenone. And the thing about rotenone is it's most toxic to fish because of the avenue that it gets into their blood. It gets into the blood through the gills very effectively. At the rate we treat, 1 to 2 parts per million, it doesn't get through people's skin. It doesn't get into the bloodstream, and it breaks down very quickly. It doesn't penetrate groundwater. And say you're treating a stream and you hit your barrier and you don't want to kill fish anymore, we can add potassium permanganate to that water, and that neutralizes the effects of rotenone. So you can actually kind of control where your removal stops, basically. So that's one thing we do, and I'll be doing that tomorrow. I was mixing up rotenone today, right before I got here. This is a typical timeline of a fish removal project. Build a barrier the first year, or you could utilize an existing waterfall. That's what they did on Cherry Creek down here. We usually do 2 years of treatments. And that's because if there's fish in the, like young a year in the gravels, they don't get usually affected by the rotenone. So we want to go through twice. After the second year, we'll go through and try to verify that the stream's fishless. We use eDNA, which is you basically filter water to detect the DNA of other fish, and then you start to repopulate.
So are you taking cutthroat out and then doing this process and then putting them back
Yeah.
afterwards?
So it can vary. If the stream that we're restoring has a conservation population of cutthroat in it, we will go through and take as many out as we can, put them somewhere else, and then use them to repopulate.
But they don't come back for 4 years?
Yeah, we'll put them in like a different stream. So I can kind of show you when I get down the line a little bit. So this is a project that I said we're working on right now in the Beaverhead. The goal is to secure a population of unaltered fish. So basically there's an existing waterfall that has kept brook trout and rainbow trout out. In about a half a mile stream, there's a few hundred fish. It's not enough for that population to survive. So in the meantime, we had a barrier built. So this is the natural waterfall where we had our pure fish up here. This is a constructed barrier that we built. And then this is the area we'll be removing fish all the way down to here. And then when we're done, we're going to use these fish and kind of spread them out throughout and probably move in 1 or 2 other populations of cutthroat to repopulate this. And our goal is typically to get a population that has at least 2,500 fish because genetically that gives you the diversity you need to persist for a longer period of time. Yep.
The constructed barrier, do you just leave that then and have an isolated population of cutthroat?
Yep.
Is that the...
Yep. And so on these small populations, we're using these wooden barriers because we can get them in for pretty cheap and they last about 30 to 50 years in this climate down here. On some really big projects, we might use like a large concrete barrier. That's just a lot more expensive. We can protect a lot more small populations with this style and then, you know, save for the bigger projects with the bigger barrier. And so this is the waterfall on Upper Cottonwood, and you can see it kind of goes all the way up, but that's what's protecting the population right now, that small population. This is what will protect the whole population.
Is it not cost effective to move the non-native fish somewhere else versus killing them?
We have done that before. Typically we're killing, you know, we're not killing like a large valuable recreational fishery. We're killing little tiny brook trout or something like that. If we were in a big river and someone's like, there's giant browns in there, we would move them somewhere else. So this is just some of the preliminary work. Oh, I also want to point out, I had a picture of a rotenone can before with green water around it. That's just dye that we add to it. The rotenone is not green. So it helps us kind of track where it's going and make sure we're getting all the water in there. This is the same kind of dye that they use plumbers use to look for leaks in like your pipes and stuff like that. But there's a little bit of pre-work that goes into this. And so this is then what our treatment looks like of cottonwood or any typical stream. We'll have different drip stations scattered throughout the drainage. And, you know, we turn a can over, it runs for 4 hours. And then we do that twice and go back and try to verify that it's fishless before repopulating. So second treatment is tomorrow. And so now I just want to give one more example of a project. This is one that was a successful project that's done and we've walked away from it. But just across the hill in the Ruby River, Greenhorn Creek, built a barrier, did 2 years of treatments, confirmed it to be fishless using eDNA and electrofishing. And then basically 3 years after building that barrier, we started repopulating it with neighboring populations of cutthroat. So about 700 fish from 6 different populations. So about 230 fish a year were moved in. And now we estimate that that population's at about 15,000. So went from 700 to 15,000 in 5 or 6 years. So that's just the kind of, that's the goal. That's the success that we want, because then, you know, we have a huge source of fish. This is just a little map of the area showing where and when. These are all different populations. So if you notice, cottonwood, the one that we're protecting right now, was also a source for greenhorn. And that's the other thing, as more and more we protect these, we have more sources for repopulation. We also transferred 6 populations of cutthroat last year that we couldn't get barriers on. And I just want to point out one, because this goes back to your question. We were doing a removal project on Andrews Creek in the upper Big Hole. We removed about 120 cutthroat out of there. That was all that was left. And we moved them over to a fishless stream in the Pioneer Mountains. They're going to be there for a couple of years till we're done with this, and then we'll use those fish to repopulate that stream in the future. This is just us transferring fish into fishless habitat. So now I'm going to get into the Madison River specifically. So currently in the Madison, we've got 18 conservation populations of cutthroat. I know the table before said 20, but it's breaking a couple into 2 separate ones. For example, Greylink Creek has a tributary called Last Chance Gulch, and I think that table counted almost 2 populations. So, and as I mentioned, the percentages, the Madison is actually one of our highest. And that's, like I'm missing a slide. I don't know how that could be, but anyways, I'll just talk about it. The reason the Madison is the highest and has the most miles compared to historically occupied is because of 3 really large projects that were done. So Cherry Creek, I don't know if you guys are familiar with that project. It was very controversial back in the day because it was really one of the first that we've done out here, and it was really big. But right now, above a natural waterfall, we have 60 miles of Westslope cutthroat trout that occupy that stream. Additionally, the Yellowstone Park has a population in Grayling Creek of cutthroat. That's about 35 miles, I think. And then the Upper Gibbon River is another 30 miles. So you've got, I think it comes out to somewhere around 120 miles of cutthroat trout in just these three big populations. So that's the reason that the Madison has such a high percentage. It was really,
Ask you a question.
yep,
Cherry Creek and history, that being one of the first projects that y'all did, 10 terms.
yep.
Positive about that. My question though is, that was a long time ago, and since then, the access of those trout to the lower Madison, vice versa, rainbows and browns going up. Speak to the success of managing the rainbows and the browns that can go up that creek.
Well, so they cannot get they can't get above the waterfall.
Or they kind of,
No. So the cutthroat trout above it are protected. But what is happening, I know, is that the cutthroat can still move downstream. So you're getting movement of cutthroat downstream. And I know people are now catching cutthroat in the Madison, or they're catching them in the lower part of Cherry Creek below the barrier, when they're mixed in with non-natives there. But
where Cherry Creek empties into Madison, how far upstream Cherry Creek is the waterfall?
it's farther upstream than you think, than I thought. I was surprised when I first saw it. Are you familiar with it? Yeah. Yeah, it's well onto Turner's property. So it's, I can't remember exactly, but this outline shows, it's a good distance of stream in between. So, yeah, so we're not worried about the non-natives below the barrier. That's just, we're letting them be just above, yeah.
Another kind of basic question.
Yep.
You talk about the Yellowstone cutthroat.
Yep.
Is it any different than Jackson Hole cutthroat or Elk River in Canada cutthroat?
Yeah, it is different because Elk River and Canada cutthroat are actually Westslope cutthroat. So they're the same ones we have here. Yellowstone cutthroat, so there's the Snake River fine spotted cutthroat. That's actually another subspecies, depending on who you ask, but I think they've evolved from the Yellowstone cutthroat. So.
And they're called spotted?
Yeah, I've heard them call it the Snake River fine spotted cutthroat. But it's just basically a variation of Yellowstone cutthroat. So. Wanted to talk about one more project in the Madison. This is an ongoing project. Finished treating in 2013. Started repopulating in 2015. And the cool thing about this project is those larger projects that I just talked about were repopulated using Westslope cutthroat trout, but they weren't Westslope from the Madison River. And in fact, some of them were from the Columbia River, so over the divide. Ruby Creek, we're repopulating 100% with some of the last remaining Madison populations. So we're using this Last Chance Gulch, which is just inside the park boundary, and McClure Creek, which is one of the tributaries to Hebgen Lake. This year we're going to use another one, and we just got genetics back. It's 99.9% pure. It still counts as a conservation population, but we know these are 100%, so we're waiting to see if we're going to move any more fish in there. I don't know, but Ruby Creek is slowly getting repopulated with an entirely Madison River population. So that's all I was going to say for cutthroat, Westslope cutthroat. I'm going to move on to grayling, unless you guys have questions, or you can wait till the end too. So Arctic grayling are one of 5 species of grayling that exists worldwide, but it's the only species found in North America. Northern Europe and Asia have different types of grayling as well, but Arctic grayling are the only ones here. In the lower 48 states, there were glacial relic populations in Michigan and Montana in the 1900s. By the 1930s, the Michigan population was extirpated, and the Montana population was greatly reduced. These fish were also first documented by Lewis and Clark. Someone in the crew caught one on the Beaverhead River, right where Clark Canyon Reservoir is right now. Interestingly, that was the only time in their journals that they documented catching a grayling. Whereas Westslope cutthroat they documented it a lot. Grayling they documented once. So, it's believed that grayling were widely distributed throughout the Missouri upstream of Great Falls, but maybe patchily distributed, like not everywhere. Today, there's Aboriginal populations that remain in the Big Hole River and the Centennial Valleys. And there's introduced populations in the Ruby River and approximately 20 mountain lakes around the state. And we are in the midst of reintroduction efforts into the Madison, so I'll talk about that at the end of this. So threats to grayling are pretty similar to threats to cutthroat, but they vary. For grayling, they even vary by population because the main threats to the Big Hole grayling are not the same, say, as the main threats to the Centennial Valley population. But they do include pretty much the same key factors. So the population of Arctic grayling in Montana is considered a distinct population segment by the Fish and Wildlife Service, which means that even though there's Arctic grayling spread throughout Canada and Alaska, and they're doing fine, the distinct population in Montana could be, regulated under the Endangered Species Act outside of all the rest of the Arctic grayling in the north. And Montana grayling have been petitioned for listing twice under the Endangered Species Act, both times found to be not warranted for listing. Most recently was in 2020, and the Fish and Wildlife Service determined that they didn't warrant listing because of ongoing conservation actions, specifically the Big Hole CCAA program, which I'll talk about, and the wide distribution of lakes. So all those introduced lake populations helped prevent against extinction. So our goal for Arctic grayling is, again, to ensure the long-term self-sustaining persistence of grayling in the upper Missouri. So this is actually a grayling we caught this year up in the Centennial Valley, Red Rock Creek. Get them big up there. So I'm going to go through a couple of different grayling populations, and because I mentioned their threats are a little bit different. We'll start with Big Hole grayling. So this is about a typical Big Hole grayling size. They don't get as big, but they are doing pretty well, actually. It's the last remaining fluvial population in the lower 48, and that means entirely river-dwelling population. And really what triggered Big Hole grayling conservation was in 1988 when the Big Hole River went dry up by Wisdom. It expanded conservation actions. And so one of the differences between conservation of Westslope cutthroat and grayling is cutthroat, we can isolate all these really steep mountain streams, take down native fish out, put cutthroat in, and they stay up there, they live. Grayling like to live in low gradient valley bottom streams. And so in the Big Hole, they live on private property and they live in high agricultural areas. So in order to conserve them, you have to work with private landowners and irrigators. And so that's why the Big Hole CCAA program was started in 2006. Stands for Candidate Conservation Agreement with Assurances. It's basically a voluntary program. Landowners can sign up and work with us, and we can help them manage their land in a more friendly way for grayling. Such as, when we hit key trigger points for flows, they might shut down their irrigation, or they might agree to fence off riparian areas to allow the vegetation to come back, improve irrigation structures, things like that. And so what the landowner then gets is assurances if grayling do get listed under the Endangered Species Act. These enrolled landowners don't have to do anything different. They have to just continue operating by the plan that they were signed up for. Any other landowners that weren't participating might face the restrictions that come with a listing under the Endangered Species Act. But this program has been really successful. It's improved riparian habitat. And like, for example, last year, the drought conditions were more extreme than in 1998, but the stream never went dry. So it was really low. It didn't look good, but having 4 CFS in the river as opposed to 0 enables those fish to kind of find a way into tributaries, find colder water. And so it's been pretty successful. So our goals are basically to maintain, we use a lot of genetic indices to monitor grayling, but maintain an increasing genetic effective population size, or maintain the genetic diversity. And so this graph here is a genetic, it's called the effective number of breeders. And basically, I'll show you how we calculate this, but we take fin clips from young of the year grayling and we can estimate how many adults produced that year class. And so you can see right when the program started, we were hovering down here pretty low. Since then, we've had ups and downs, but what I want you to just think about is that these are indicators of relative year class strength. So like 2019, you see we have a pretty big year. That was a strong year class. And right now, those fish are 3-year-olds. So those are our prime breeding fish. So we have a lot of 3-year-old grayling in the Big Hole right now, and we're seeing that with angler catches and through our sampling. And we talk a lot about genetic diversity. We want to maintain it. We don't want them to be inbred. And so these are 2 indices of genetic diversity, and you can see they're pretty consistent. And so this is how we collect our samples. And the Big Hole grayling spawn in late April or early May, and they grow really fast. By late fall, the fish could be 4 or 5 inches long, which is really fast growth compared to other trout. I was talking earlier, they hatch really small. They hatch quickly and they're really tiny, but then they just grow. So what we do is we go out and we try to collect as many young of the year fish as we can, and we take a genetic clip, and then we can get that estimate. And what we do is we go to known spawning areas. And so on the Big Hole, this is Wisdom right here where Highway 43 comes down, and this is Wise River. Most of the spawning occurs between Wisdom and Wise River. And so that's where we do most of our sampling. Grayling are highly migratory, so people will catch them. We caught one shocking last year all the way down to Twin Bridges, which was cool. But most of the spawning is in the upper river. Here's a picture of us out with our electrofishing barge. They like to hang out in either side channels off the main stem or in some of the lower gradient tributaries up there. One other thing about the big hole is in the 90s, a genetic reserve of big hole grayling was created. And it's actually in the Madison drainage. It's up at Upper Twin Lake in the axolotl chains. So right up the hill, right below that BLM cabin up there, there's a lake, Upper Twin, that's got our genetic reserve of big hole grayling in there. So that was created to, you know, in case something went wrong in the big hole, we'd have them reserved. But right now we're primarily using it for other projects, like other introduction projects outside of the big hole drainage, including so we'll spawn fish there in the spring, fertilize their eggs, and put them out in places. Big Hole also has 3 native lake populations: Minor Lake, Music Broad, and Pintler. Here, really all we're doing is monitoring genetic diversity to make sure it stays consistent over time. Centennial Valley is the other Aboriginal population. As you guys hopefully know, it's right over the hill from here, from the, I guess, the Upper Madison. Right now, most of the grayling in the Centennial live in Upper Red Rock Lake and spawn in Red Rock Creek. Some spawn in Elk Springs Creek. We also have some grayling in Long Creek on the lower end of the valley, but most of our fish are up here. They used to be much more widely distributed in the valley. Climate change has had an effect up there because a lot of the tributaries that used to run either no longer run or are too low to really get fish up. Also, there was tons of modifications made to streams up there in the name of waterfowl and swan conservation. They put in-stream ponds on creeks that grayling spawned in. They diverted water all over. So around 1900, there was millions of grayling, and they started to decline around like 1930, I guess. There's also a lake, Elk Lake, which is kind of up above Cliff Lake here. It drains into the Centennial. There's evidence that geologically it used to drain into the Madison. It had grayling in it until the 1990s. But now the 2 spawning tributaries no longer even connect to the lake. So the grayling just went away. There's nowhere to spawn. So we're working on trying to figure something out there and get water to spawning. But yeah, so they all live in Upper Lake, which is a high elevation, shallow lake with extended periods of ice cover. And so our goals for grayling up there are conserve genetic diversity, maintain 2 spawning tributaries above Upper Lake and below, and then manage for at least 1,000 spawning grayling in Upper Lake. And so this is what we have. Unfortunately, this is an actual population estimate. The dashed line is that 1,000, that's our goal. And you can see for the past 7 years, we've been well below our goal. You're also seeing the genetic indices declining too. So what drives the Centennial Valley population? Well, it's on a national wildlife refuge, so the land's managed by the Fish and Wildlife Service. But for years, Fish, Wildlife, and Parks and the service have been kind of debating what drives the population. And really 3 main theories came out of it. Was it the non-native trout up in the lake up there? Was it available spawning habitat or lack thereof with beaver dams coming in and inundating gravels and blocking migrations? Or was it over winter conditions? I mentioned shallow, high elevation lake. It can be under ice for 5-6 months of the year. And so FWP and the Fish and Wildlife Service got together and created this adaptive management plan where they actually experimentally tested all these hypotheses. And we continue to do that every year by collecting data and experimenting. And what's becoming clear is that overwinter habitat is the primary driver of that population. So that's the reason for their decline, is a series of poor winters for fish. And what I mean by poor winters is grayling need about 4 parts per million oxygen, and they need enough space in the lake that's over 1 meter deep to live in. And so if you don't have all those things, then that's when we see declines. And you can see that on this graph too. So this is hectares of suitable winter habitat. A hectare is about 2.6 acres. So on the years when you have a lot of suitable habitat, meaning 4 parts per million, you have high populations. And the years where you have very little, that's when you have problems. And so one question that I get asked is, well, if there's climate change occurring and the winters are becoming less severe, why aren't they doing better? Why isn't it better over winter conditions? And the answer is, it's just the amount of water that comes in, you know. So on really bad drought years, you're going in, instead of having a 6-foot deep lake, you have a 3-foot deep lake. And you have less tributary inputs coming in, you have less groundwater coming in. And so, yeah, that's how climate change is impacting the Centennial. Yes.
Well, so I still don't quite understand what's driving then more anoxic conditions.
Yeah.
Like the groundwater and those cribs are contributing much more oxygen-rich waters, or, you know, we say, right, you know, colder waters can hold more oxygen. So
Yeah.
I think winter wouldn't necessarily be bad, but
Yeah, so the way up the upper Red Rock Lake is, it has 2 major tributaries that come in and some smaller ones, but it's really shallow right by the mouths of those trips. So that whole lake is kind of mucky. And grayling go out to where it's the deepest, so they're out in the middle. And once ice cover forms, if you have clear ice, you know, photosynthesis can still occur with the vegetation, and so oxygen is still being created. Once you get snow cover and it gets locked into darkness for the entire winter, that's when they start to die and decompose, and you just see oxygen levels drop off.
because bacterial communities
Yes.
are forming.
Yeah, just anytime you have that, the bacteria, the decomposition, basically. So, yeah, that's kind of the deal. So we've looked at a bunch of ways to try to mitigate overwinter conditions. We rented a solar aerator to put out there. Oops. Near this, okay. And that's what happened to it. Covered with drifting snow, and it basically stopped producing oxygen. And so what we're working on now, what we want to do now is call it a tributary diversion, but we want to divert 2 CFS of water from this. This is like a little artificial reservoir and creek. We want to run an underground pipeline out to the middle of the lake where they overwinter, and just try to, it would be a passive operation. We've already raised a lot of money towards it, but there's not unanimous support for it. It is the wildlife refuge is in a designated wilderness, and it's a big birding area. So we're working through that, but that's what we want to do, is moving forward, is divert water out to the middle. Real quickly, I talked about Elk Springs Creek as another tributary. This was maybe the primary grayling spawning tributary in the Centennial back around 1900. Then someone decided they needed more waterfowl habitat up there, so they dammed the creek up, built a big pond. That was in place from the 1950s through 2009. 2009, it was removed, and Elk Springs Creek was a creek again, except that it was really over widened and silty. It's a spring creek, so it doesn't get it doesn't get snow melt flushes. It's really constant flow. So all that silt that settled there was just there. And it was over widened and shallow. Didn't really look like a grayling stream. So we just finished up this is phase one. We finished up our second phase last year where we're basically tightening up the channel and making it more livable for grayling.
How many phases?
Just two.
Okay.
Yeah.
And you'll-
Yeah, so we basically covered that entire footprint of the old pond from here to here. That was what was most impacted.
Nice.
Actually, I think we even went above. So. We're also working on creating a brood population, like I mentioned, for the big hole up in Upper Twin Lakes. We've got a big hole brood genetic reserve. We're working on one for the Centennial Valley right now. I'm going to skip some of that. Skip a couple slides. We are spawning fish. We were talking earlier about taking eggs. So that's what we're doing, taking eggs. Spawning fish. I'll talk about the Ruby River grayling because this was a successful introduction. Historically, grayling lived in the Ruby and they were extirpated. I've heard the 20s, I've heard the 70s, but at some point they weren't there anymore. And it was identified as a really good spot to try an introduction because of some of the favorable characteristics. It was a large river above the reservoir, 41 miles. Grayling are migratory. They need space to move around. It was very low gradient, which is key. There were some good deep pools and there was low densities of non-natives. So we thought this would be a good place to try it, and it worked. In 1997, they started stocking fry into the stream. But it really wasn't until 2003 when they started putting fertilized eggs directly into the stream in artificial nests that they started to see success. And so they did that for 6 years, and then they documented natural reproduction of grayling for 8 more consecutive years. And so now we're just on a basis of monitoring. We go in there every 5 years, make sure that the fish are still doing well. These are just pictures of some of the artificial nests that we use, and we're currently using these on the Madison, and then these are fertilized eggs just going straight to the gravels too. And yeah, our goal here is just maintain genetic diversity and supplement if we see a problem. If we see numbers go down or diversity go down, we might supplement with other populations. I mentioned the mountain lakes. We've got 20 mountain lakes of Montana origin grayling around the state. Similarly, our goals are just to maintain genetic diversity. So you can see these are, again, this is heterozygosity, this is allelic richness, but it's just measures to make sure they're not inbreeding. And you can see in lakes that we have multiple years, these indices are pretty consistent. So, so that's good. So finally, onto the Madison. You know, the Madison River had grayling, and it was one of the bigger populations ever. A couple things happened. I think the creation of Hebgen and Ennis dams inundated a lot of the spawning areas where grayling spawn. There's some springs that they use reportedly. So that eliminated a lot of habitat, but they still existed in Ennis Lake until about the 90s. And, you know, now we think it's primarily just the densities of non-natives, brown trout especially, that prohibit them from kind of existing at least at sustainable levels. So our goal is to establish 2 viable populations in the Madison, and that includes Yellowstone Park. And beginning last year, we started to focus our efforts on Hebgen Lake and its tributaries. And one of the reasons is because a lot of those tributaries have lower densities of brown trout. Like brown trout use those tributaries to spawn, but then they go back to the lake. There's not a ton of just resident fish up there. So we're trying the South Fork, Madison, Black Sands Creek. And then in the park is working on Grayling Creek and the Gibbon River, trying to get grayling back in there. And so we work with them to get them grayling to use. And a lot of those grayling actually come from that upper twin. And just wanted to show real quickly, so in that Hebgen Lake project, last year we were hoping to put a lot more fry out. We did not. We put about 150,000 eggs out and 7,000 fry last year. This year, we've already put out 500,000 eggs into the South Fork, Madison. So that's pretty good. And then we're working, Grebe Lake and the Gibbon was stocked in 2018 with grayling, and we're going to try to get them more grayling this year to get up there. Grayling Creek is one that they're trying to get a stream population going. Problem is it's really high elevation. And so when we're spawning fish down here, the eggs are ready to go out in incubators in May. But up there, there's still 3 to 5 feet of snow on the ground. So I want to work with them and maybe next year get like a higher elevation site, get fertilized eggs later in the year, try to get them out into Grayling Creek there. So that's about all I've got. Just wanted to end it on a slide with a couple other native fish to the Missouri. We've got burbot here. They're spread out throughout the Missouri. And then if you didn't know, there are 2 populations of native lake trout in southwest Montana. They've been Elk Lake in the Centennial and Twin Lakes in the Big Hole. So
We have an active population of burbots anywhere catching.
I don't know if you can in the Madison. You can in the Clark Canyon Reservoir.
Helena.
Yep, Helena. All the Madison reservoirs down the way have them. The Big Hole's got them all over the place. I think they were outfished from like the Cliff and Wade Lakes areas. I think they were native and they're gone. And I know Mike Duncan, who's the management biologist for the Madison, has been talking about potentially trying to reintroduce them from somewhere over the hill. And I mean, this is Elk Lake and the Centennial. There's a lot of these little guys. And like I said, there's evidence that at one point it drained into the Madison. So, you know, that would be a potential spot. Big Hole's got a ton. We could potentially move them. But there's, you know, early stages, not really official proposal yet.
You typically catch those fish when they're lake trout fishing, like canyon fair.
Yeah, most people I know that fish for them, and I'm not a big burbot fisherman, but it's through the ice and it's at night. That is the primary way to catch them.
I caught one fishing for walleye. And it was very tasty.
And what were you using, bait or? Yeah, so I'd say bait is probably the way to go, like
Yeah,
bait on the bottom.
like trout. I was just up out of Saskatoon last week,
Oh, really?
fly fishing, and some big lake trout, and some milton. Guys were fishing for lake trout, catching bourbons.
Really?
As you know, they're really good to eat.
Yeah, yep.
So you're, they have to. We're gonna get to a point where. That for say, look, 10, 20 years down the road.
Yeah, I would say that for cutthroat trout, they are, they will be sustainable with minimal maintenance. You know, like the barriers don't last forever, but they last for decades. So it's the cutthroat really are a project we can do and then walk away from, like that greenhorn one and the ruby I mentioned. I mean, we're done with that for a while. We'll occasionally monitor it, but it's pretty sustainable. For the big hole grayling, we're in a pretty sustainable place where we're mainly focusing on monitoring at this point. You know, Centennial, like I mentioned, we're trying to get this project done to kind of fix the over habitat conditions in the lake, and that's been quite a battle. I've talked to other biologists who have installed similar pipelines to fix these problems, and they're pretty maintenance free too. So if we can get something like that to fix the lake conditions, I think, you know, we can really step away from that one for a long time too. Yeah, I mean, it's different than where I used to work in northwest Montana, where there's a lot of dams and you have migratory bull trout, and we're building fish ladders and we're actually driving fish around the dams. And, you know, I'd say that's less of a sustainable recovery. I mean, it's probably necessary, but I would say what we're doing is pretty sustainable. Or does that answer your question?
Yeah.
Is there anything going on in Upper Wigwam and Arista and that area?
Yes. I believe, I can't remember off the top of my head, I believe Wigwam's got a conservation population. And does Arista too, or? I don't remember.
Thought so, yeah. My recollection anyway. Is
Okay. I can't remember if Wigwam has a barrier on it or how to construct
Yes.
it. It does? Okay. So, yeah, I don't know currently, but yeah. Yep.
What made the introduction of lake trout into Yellowstone Lake impact the cutthroats in the river as well as in the lake?
Well, I mean, the cutthroat, all their life history around the lake is that they use the lake and the rivers. So they're getting hammered in the lake, and that's impacting the river populations. You know, they're just getting eaten in the lake, basically.
The river isn't a separate population.
No, not, I mean, until you get way farther down or maybe way higher up. But yeah, a lot of the big spawning runs were all lake dwelling fish that moved in or downstream to spawn. So, yeah. And then I think the cutthroat got hit with a couple things at once, like whirling disease in the tributaries and drought and other things like that. So there was multiple factors influencing them at the same time, basically. So.
You say that they're grayling.
Yes.
I actually was very lucky I caught two.
Oh, really?
Back in the nineties. But a lot of people looked at me with a little bit of like, really?
Yeah,
Now I got you out.
Yeah. yeah. And there may still be some.
But
We don't,
if you-
we don't see them in our sampling. The past couple of years, we've tried introductions in some of the creeks around here, like Moore's Creek and Blaine's Creek. We didn't see any returns, but temporarily those fish could have gone down into Ennis Lake or the main stem. We just haven't seen them actually spawning and recruiting back into the population.
It's not related to these two, but how's the whitefish population in the river?
You know, I remember there was a grad student that was studying it for a number of years.
Funded that study.
Oh, you did? Yeah, I thought her results said that it had declined. That's about all.
Hasn't been much research.
No, that's about all I know.
Oh, God.
Yeah.
Maybe 10 years?
Yeah, well,
Better
before
part of
enough
10
time.
years.
Like 7.
No, that was that the beginning? Good for 2 years.
Yeah.
God, was that long ago?
No, I said it's been at least 7.
Oh, at least, okay, I'm sorry. Okay. About right.
Studies that they've done. Oh,
Yeah.
Native lake trout.
Yeah.
I didn't know about that.
Yeah.
I hail from like Great Lakes area, right? And I guided in Yellowstone National Park for
Okay.
5 years. And so the story was always like, the lake trout are doing so well in space
Yeah.
out here in Montana. And
Yes. And so these two populations are, they're basically, these were like glacial refugia where the populations were stuck. And I think the reason we know it is, one, looking at old journal articles, people were catching lake trout back in the day, but the genetics of these fish, Twin Lakes and Elk Lake, match with those of northern Canada. And the genetics of all the introduced populations match with the Great Lakes lake trout. So, yeah, pretty interesting.
just don't put burbot, bull trout, and lake trout in the same watershed.
Right.
So we nothing else.
Yeah.
there are other places of Asia.
No, but on the east side of Glacier, there's a couple. Yeah. Yeah.
Any other questions? Thanks, Ryan.
Thank you.
Thanks for your hard work. Appreciate it.
Oh, thank you.
Did you want to show that video real quick? I forgot.
Sure.
You don't have to, but.
Yeah, I'll show it real quick. This is just a video of grayling hatching in the South Fork Madison this year. And a coworker of mine put it to music, so. It's Travis Lorenz. So if you can see all these little things, these are all grayling fry that are emerging. And I mentioned we put out 500,000 eggs this year, so. But he's just gonna go right back to, I'll show you the little artificial nest that we put the eggs in. So this is his artificial nest, and you can see they're swimming out, they're emerging and all that. So those fish are out there this year, and hopefully, hopefully we'll see some returns in a few years, maybe.
Tilo, yeah, put that music.
Yeah, Tilo did that.
Exactly.
Yeah.
Say
So,
goodbye.
yeah, I'll be working with Tilo in the morning. He's coming over to help us do that project, so.
All right.
Cool.
Thanks for showing that.
Yeah. Well, thanks, everybody.
Yeah, thank you.
Did you ever do much work in Yellowstone and Broad Creek? Did you go to Broad Creek with the cutthroats or with the Yellowstone cutthroats?
No.
Oh, okay. Years ago, I
At
believe in.
least once. I'm sorry.
Pension some.
Crazy with that.
Yeah.
I'm sorry. I just like.
How big do these?
And don't, yeah.
The Westslope. In a lake, they can get over 20 inches. I mean, in some mountain lakes, they can